Today's world is very concerned with the environment, and automotive manufacturers are focusing heavily on energy-saving concepts. Where many are looking to optimize the engine in order to solve this problem, Audi is investing a larger strategy. In addition to assembling more efficient engines, Audi is at the cutting edge of another method, lightweight construction. The best way to implement an automotive concept is to use this synergy of dynamics and efficiency by using lightweight construction as a basis. And for those who think weight isn't that important, they might be impressed to learn otherwise. Audi recently invited specialist journalists from around the world to its TechDay Lightweight construction demonstration in Neckarsulm. Experts from Audi showed its advantages by proving the way in which lightweight construction reduces fuel consumption and emissions, and they didn't only do it on paper. The journalists were shown firsthand through comparative drives with serial models and lightweight construction prototypes how effectively the lightweight construction increases the dynamics. And then they were shown how. Contrary to popular belief, it's not simply the body of the car that is developed to make it lighter. It's much more complex than this and involves many different areas. For example, because different materials are different weights, they are used in a variety of ways for each part, as with the spring strut mounting. As you can see on the scale, it weighs 15.4 pounds, 8.4 pounds, 5.7 pounds. Naturally, Audi would want to implement this potential in future automotive projects. On certain places, we can also imagine using magnesium. We have developed simulation tools where we can also use aluminium castings to reduce the weight of the parts while still being able to withstand the pressure which we're aiming for. For some time now, aluminium has been used by Audi due to its lighter weight compared to steel. The aluminium tailgate of the Audi Q5 is over 17.6 pounds lighter than it would be if we use steel. However, there are always two sides to every coin, so new aluminium poses challenges to the engineers. Unlike steel, aluminium bounces back after bending, which means the tools must bend the material significantly to obtain the desired form. As you can see, after bending, the material bounces back into almost its original shape. This is the challenge, to work a material with such characteristics into specific bending shapes and narrow angles in a millimeter's range. The Audi space frame applies the bionic principle that we know from the elephant skull. You see all these ribs here? It is the principle of only placing material where it is needed. Furthermore, due to lightweight design's aim of combining the best suited materials, each combination has to be constructed using the most appropriate method. Some are welded, some screwed, and some bolted. The roof and side frame of the Audi TT, for example, must be welded, and due to high Audi standards regarding aesthetics and design, the weld seam must be virtually invisible. In the past, we used to apply a plastic trim strip to cover the weld seams, but now for the first time we were able to employ a laser welding process for aluminium that joins different body parts without a visible weld seam. 2.2 pounds of weight saved in rotary masses produces the same effect as up to 35.3 pounds saved in translatoric masses. It's obvious to say that to make a car move it requires energy, but due to the fact that the car has moving parts, which are its rotary masses, it actually requires much more energy to make it move in the first place than you would think. More energy equals more fuel consumption, And this is the reason that Audi is so intent on reducing the weight of its rotary parts.
Es handelt sich hier eine Keramikbremsscheibe.
This is a ceramic disc brake. It saves up to 23 pounds over a conventional disc brake. The applied technology of the exhibit on the right is the flow form process, which saves up to 29.8 pounds. And over here, we see an entirely new technology. It's the so-called hybrid wheel. It's made of two components which enable us to save on some material here in the structure. This amounts in reduced weight of up to 7.7 pounds per part.
Und damit haben wir hier eine Gewichtsreduzierung von 3,5 Kilogramm.
And out on the test track, the journalists had the chance to see just how much reduced weight enhances the dynamics of a vehicle. Test vehicles were an Audi A3 24-hour street and two Audi A5s, one of which was a series production model and the other a lightweight prototype. The A5 lightweight prototype weighed 529 pounds less than the A5 series production model. And even though the engine of the series model was a 265 horsepower 3.2-litre V6, and the lightweight prototype only had a 211 horsepower 2-litre TFSI engine, they still performed the same, with the prototype consuming a litre less fuel over 62 miles to boot. The Audi A3 24-hour street, whose like-named road-going version raced the 24 hours of the Nürburgring, came in at about 441 pounds less than its series production counterpart. It shows the potential inherent in lightweight design. It has 300 horsepower, 390 Newton-meters torque, and 2,624 pounds of weight. The Audi space frame principle has so far delivered great secondary effects. A lighter car body will result in reduced weight for other parts, such as the chassis or the tank. And in the end, the engineers are convinced the results will be the reversal of the weight spiral.